Hi Manikanda.
Hi ma'am.
Can you briefly introduce about yourself?
My name is Manikanda. I pursued my BTech from BIT Narsapur. I pursued BTech from BIT Narsapur and my CGPA is around 7.3 to 7.5 and I'm very interested to work in domain like VLSI and analog circuits, and have worked and developed my skills in Verilog, SystemVerilog, and some particular boards like FPGA ping boards, Z boards. And also I'm very likely to work and apply my skills in industrial level so that I can get some more knowledge on VLSI and other things.
Okay. Have you done any projects in VLSI regarding
Yes, ma'am.
SOC level or any protocols?
Yes, ma'am. I have done one project in my second year, EOR protocol, but I didn't implement it in like a coding way. I just implemented on like how can I say? I just prepared a paper and I explained what is what about the protocol, and that's it, ma'am. And in my final year project, I have done a project to test the health of a plant using a ping board, and they will use a Jupyter platform to write a Python code, and we also use machine learning to to read the data set or to train the data set.
Okay. Okay, so you have worked on FPGA boards using Python and all. Okay.
Yes.
Can you explain me how FPGA boards are used in VLSI?
Yes, ma'am. Here, when we implement a design, we cannot dump into an board because it's very costly, and we can sometimes it may exceed our expectations, like when we're going to pricing. So to come over that, we created FPGA where we can dump our program and test our design is properly working or our logic is properly going on or not. If it is okay in FPGA, so then we can move to PD, so PD level, where we can design the board directly on silicon chips.
Okay. So how can we verify a design RTL code while we are dumping into the FPGA? So functionality wise, whether it is working correctly or not, how can we check it?
Yes, ma'am. It depends upon board, ma'am. Some boards have displays, LED displays, and some boards don't have any displays, and just we need to have some practical, not practical. How can I say? Just expected values. We need to write down the expected values, and there will be an showing of lights, ma'am. There will be an showcase of lights where we can know that if the light is off, it's 0, and when it light is on, that is 1. According to that, we can check whether our expected we are getting expected output or any errors. So if there is any error, we can go back and correct in design level.
Okay. So in your training period in VLSI, what you have learned and what experiments you did or what projects you have worked till now?
When I am at college level, I haven't gone depth, ma'am. So after joining the coaching center, Verilog, I have done in very starting, and I have done a project on LFSR where we use clock gating approach and also polynomial things and everything we have done in LFSR project. And after that, I have designed a linear scrambler which we use in PCIe protocol, and also I have done a project on MIPS, and which is not pipeline. So till now we have learned many things from Verilog, ma'am. Now I'm getting into SystemVerilog, where I'm started learning from how to write test benches, and just completed my basic level of writing course in SystemVerilog.
Okay. So you have completed MIPS processor, right?
Yes, ma'am.
So can you explain briefly about what is meant by MIPS and what is the difference between pipeline and non-pipeline?
Yes, ma'am. It's MIPS nothing but a million instruction per second, ma'am. If you take any example, general example like phone, we are operating phone. It take at a time we can use like WhatsApp or anything, something like that. So the processor have to take a million instruction and give the output properly. So there we use MIPS, and there we have pipeline and non-pipeline. So in pipeline we have it takes more time comparatively. Sorry, non-pipeline takes more time comparatively pipeline. What happens in pipeline, non-pipeline? If the complete instruction is done, then only we can pass the next instruction. But coming to pipeline, where we can, after passing one step after parallelly, we can execute our instructions, so that our execution time gets slower and we can make the device faster.
Okay. Okay, so in pipeline, as you are telling, the stages gets like multiple stages
Yes,
will
ma'am.
execute at a time. So without completing the one instruction, the second instructions merge into the cycles and it will work
Yes,
accordingly. So that how can we calculate the CPU time further?
Then we take that the frequencies of the two receiver side and output side and receiver side and transmitter side. Then according to that we'll calculate the time period, ma'am. We know frequency is called so 1/t. So from there we'll check our time difference, so that we can add some memories to synchronize the transmission between two levels, ma'am, so that it stops, how can I say it stops losing data without any interference or like that.
Okay. Suppose I will give an example to calculate a CPU time. Just a second. Can you tell me what is the formula for CPU time?
I think first we need to calculate the time period, ma'am, of f is equals to 1/t. After that we need to check how much of data is transferring, like how much of data transferring into time, so that we know how much time does it taking to transfer data. So according to that we'll take a memory between two components, where we can match the speed of input and output.
Okay. Then how can we calculate the speed, clock speed? Like how can we calculate the number of instructions executing per cycle?
I don't remember the formula, ma'am.
Okay. Okay, fine. How would you rate yourself in digital logic design and Verilog HDL?
Yeah, if it is out of 10, I'll rate myself around 8 to 9, in between 8 to 9, ma'am, in digital.
Okay.
But coming to Verilog, I can say that I'm good, ma'am. I can rate myself from 9 to 10.
Okay. Fine. In Verilog HDL, what is the difference between synthesis and simulation?
Yeah, in stimulation we'll check. In stimulation we'll get then what is the design errors, ma'am. Whatever, if you are designing something, what the syntax error that will be come from the simulation. When we go to synthesis, where we can get our RTL design or netlist, where we can check our design is perfect or not. And also we can, from stimulation we get waveforms in Vivado tool, and there also we can check our test case are working properly or not. In synthesis we can get power analysis and other things also, ma'am.
Okay. In Verilog HDL, we use the behavioral modeling, right?
Yes, ma'am.
So what does it mean?
Yeah, actually we have two types of actually we have three types of modeling: gate level modeling, structure level modeling, and behavior level modeling. Here gate level we use gates, ma'am. Here gates. In behavior level we use truth tables, ma'am. So in structure level we use truth tables, ma'am. In behavior level we use equations, ma'am.
Okay, go on.
So I think it's not. I think it's not structure, ma'am. It's data flow where we use where we use the logic equations or design equations. Coming to behavior, where we use truth tables to implement the design. That's it, ma'am.
Okay, so we use the truth table in behavioral modeling.
Yes, ma'am.
Where it showcases the functional behavior of the design.
Design, ma'am. Yes, ma'am.
Right. So, what is the syntax or what is the design construct we use in behavioral modeling?
In behavior modeling we use always block, ma'am, and also we can use initial blocks. Here always blocks is repetitive, ma'am. It's like it's infinite loop. It always until unless we give an finish or stop statement, it won't finish stop, ma'am. But initial statement it executes only once, ma'am.
Okay. Is the initial is synthesizable?
Yes, ma'am.
How? Can you explain?
When we are yes, ma'am. If you are, I think it's not something.
Can we use initial block in design?
Sorry, ma'am. We cannot use initial block in design.
Then how it is synthesizable?
No, ma'am. It's not synthesizable. We use we use initial block in test bench only, ma'am.
Okay. So can you tell me more differences between always and initial? Like what are the rules we need to follow when we use the always and initial, like in terms of data types declaration?
Yes, ma'am. Here in always block we have a sensitivity list where if you are designing any combinational circuits, we can directly put a star representation so that it can take every input output variables. But we here in initial we don't have any sensitive block. There it is one difference, ma'am. And both initial and always block, the LHS side should be rich type, ma'am. And as I said, always block is repetitive, and initial block it's only single loop, ma'am.
Okay. Can we use always in test bench?
Yes, ma'am. Here we'll use to generate clock, ma'am.
Okay.
Yes.
Fine. So, in always block, to write the functional behavior, we use some case statements and if else.
Yes, ma'am.
Correct? Okay. Can you explain me the behavior of the case and if else if we do the synthesis? After doing synthesis, what type of circuit it will be generated?
Yes, ma'am. If you use if else, the circuit will be generated sequentially, one after the other. But when you use case statement, the overall function of the design will be same, ma'am. But while coming to RTL design, the structure will be different from case and if else, ma'am. Here it forms sequentially. Here it not exactly sequentially. How can I say, in a vertical horizontal in that terms. If we use if else, it goes continuously. But
what it is? What type of circuit is?
What type of circuit? I am not getting it, ma'am.
Generally, it is a multiplexer.
Yes, ma'am. Multiplexer.
How it will be generated? If else or case means it's a series of multiplexer.
Yes, ma'am.
Case is nothing but based on the control signal the output
Yes,
will be
ma'am.
getting. The control signal is nothing but what the selection line of the multiplexer. Okay. Okay, fine. Next, in Verilog HDL, can you tell me what is the difference between dollar display and dollar write?
Yes, ma'am. Here dollar display it don't have the next line condition in it, so it generates in single line. But coming to display, it generates in, and in display it only gives the output of last updated value or initial values. But same coming to your same operation, but only the difference is it generates in single line, it generates in next line.
Okay. In dollar write, it doesn't add the new line. In dollar display, it adds the new line. Okay. Then what about monitor, dollar monitor?
Here dollar monitor said like the work it works as display, but difference is display prints only a single statement. But coming to dollar monitor, it monitors every statement and every input values, and it gives every output on the display. What we are according to the things we are giving in the monitor log.
Okay. Okay, fine. Can you write a piece of code for generating the clock using always, forever, and repeat? Always repeat a piece of code for generating.
For repeat and forever, just given a logic.
Okay. Okay, let me give you a piece of code and just correct me if I'm wrong.
Here B is declared as while. Coming to procedural blocks, we cannot declare LSI as a while, so we'll get it as an error now here.
Okay. Then how can we fix that error?
Just we can change it as it to be rest, or we can write it in continuous statement. If we use procedural, we need to be we need to be sure that the LHS should be rich.
Okay. Okay, fine. Do you know about randomization in Verilog?
Yes, ma'am.
Okay. So why do we need the randomization?
Here, if you have multiple inputs, we cannot sit and write for every input and different. So if we take something like if you have 10 inputs, ma'am, and each has around 7 bit input, we cannot write every input directly because it's too lengthy and it takes time. But if you use dollar random syntax, it generates randomly, but one problem is that it generates repeated values, ma'am. That's one problem, and we cannot be sure that every test case is covered or not when we use dollar random.
Okay. Can you write a piece of code to generate the random value between 0.5 to 0.9?
Yes, ma'am. I can give
just
you.
Just write that equation, like whatever
Yes,
the expression.
Yes, ma'am. Let's take from where to where, ma'am?
0.5 to 0.9.
Okay. Here, ma'am. Actually, here we take 0.4. For actually, it works for every logic when we are generating and floating point values between 0 from 0 to 9 or 0 to 1. Here, first we need to check from where to where we are generating the values. So if you are generating the values from 0.3 to 0.9, for example, we need to take the difference. Like if it's around 6, ma'am. Here we need to generate the random values up to 6, ma'am. So that if you add if you add 1, it goes from 0.4. If you add 2, it goes to 0.2. Here the mod 10 makes 1 as 0.1, 2 as 0.2, 3 as 0.3. This is the logic. It will work for every.
Okay. Can you write a logic for generating the random values like multiples of 3, like 0, 3, 6, 9? It should generate only multiples of 3.
Yes, ma'am, I can try.
Okay, I can give you a hint. Suppose if we want to generate even values or odd values, how can we check whether the condition is even or odd?
I will take an if-else condition.
How?
Like if it is even, if it is divided by 2, it's an even number. If it's not dividing with 2, it's an odd number.
Okay. If modulo is equal to the 0, then particular value will get even value or if not 0. In the same way, even value means mod 2 we do. So the multiples of 3 means how we can do?
We can divide it with 3, ma'am. So we
not division. You need to tell it's a modulus.
Yes.
So that it will give the remainder value.
Yes.
The remainder value will tell what value it is, like even or odd or multiples of 3, multiples of 5.
Yes, ma'am.
Okay.
That's
A mod 3 is equal to 0, then A equal to $random. Okay. So here first you are doing A mod 3 equal to 0. Okay. If it is a multiples of 3, then only it will do the randomization. The statement is wrong. I told you, every value should check, like within $random only you need to put n mod 3 equal to 0, like $random mod 3 equal to 0, like that you can write. Okay, just check with this concept. And what is the difference between u random and normal $random?
U random generates sequentially, ma'am. Like if we give the number, it generates from 0 to 5 continuous 0, 1, 2, 3. But random, it generates randomly, ma'am.
No, it's wrong. U means which indicate unsigned. It doesn't generate the negative value. U means specifically for positive values, or else within two curly brackets we can mention the $random, so that it will indicate only positive values. It generate only positive values. Okay. Next, So in Verilog we have randomization concept. Okay. If I want to generate the specific values according to my requirement, can we use the same $random to write the
No, ma'am.
required values?
No, ma'am, we don't have that kind of syntax or anything that works in Verilog, ma'am. If we want to generate specified values, we need to write our code or test bench in SystemVerilog, ma'am, or UVM.
Okay. Okay. Suppose I want to generate the value specifically to 5, 6, 7, 8.
Yes, ma'am.
So how can we do randomization in SystemVerilog?
They will use constant, ma'am. We use constant command, and we will mention that we need to generate only 2, 5, 3, so that it randomizes between 2 and 2, 5, 3 only, ma'am.
Okay. Okay. So the constraint is mostly used for
Specific
controllability
of the randomization.
Okay. Okay. Fine. Okay. In digital electronics, you have completed the digital logic design also,
Yes,
right? Okay. What is the main importance of finite state machine in real-time application?
Here, coming to final state machines, ma'am, here, we cannot generate complex statements using combinational or sequential circuit, because it takes more time and more space to cover it, ma'am. But coming to FSM, here we can design complex circuits like FSM, as well, not FSM, like ATM, vending machines using FSM, ma'am. And also we have two types in FSM, ma'am, like melee and mole. And mostly we prefer more FSM, ma'am, because it have more number of states comparatively melee, and its output depends only on the current state. But in melee it depends on both current state and current input, so that it may not suitable for every application in real time, ma'am.
Okay. Okay, fine. Can you tell me what is the difference between register and a memory?
Register is a temporary storage element, ma'am, but memory is like a permanent. Now, not permanent. If we can, according to our requirement, we can store the data in it, ma'am.
Okay. Okay. So in memories, what are the different types of memories are there?
Yes, ma'am. Like last input, first output, first input, FIFO, LIFO, SRAM, DRAM, DDR, RAM, ROM, dynamic RAM.
Okay. Can you explain me what is the difference between RAM and FIFO?
Yeah, yes, ma'am. Here, FIFO, we can how can I say? It extracts buffer medium between any two components where the frequencies are different, so that they can be synchronized. But coming to RAM, it's an completely storage element where we can store the data depends on what we are doing and what things we want to store on it.
Okay. Okay. Okay, you told frequency, if there are frequency mismatch between the two different circuits like a transmitter and a receiver, we use the FIFO memory. Okay. Yes. Can you tell me how can we make the synchronization between two different components using FIFO?
Ma'am, if the transferring speed of the one component is speed and receiving speed of other component is slow, while transferring it may lose data, ma'am.
Okay.
So because it cannot accept that, if you are transferring 10 transaction at a time, ma'am, but it can accept only 5. So here what happens, if we transfer directly 10 number of transactions, we do 10 number of transactions, it can accept only 5 number of transactions, so that remaining 5 may get lost. So that to come over this, we use FIFO in between those. Here, if FIFO works, when we that 10 transaction will be stored in a FIFO for a temporary time, and it sends according to the requirement. First, as I said, it shares 10 and we write the 10 transactions in FIFO, and receiver side it takes according to its requirements. It takes first 5 data, and because it's a FIFO, first input first output, it gives the first written data as an output, so it can match the receiving transmission speed now.
Okay. Suppose there is a and B block, transmitter and receiver. Suppose A frequency is greater than B frequency. Okay. So A frequency is 80 megahertz and B frequency is 50 megahertz. Can you calculate the depth of the FIFO?
I'll try now. Sorry ma'am, not getting it.
Just explain me the process. How can we do?
Here we check the speed of the transactions, and according to that speed we'll design a FIFO and we'll connect it to the output, like receiving side.
Okay, actually it's a very simple question. You just look into it once. Okay, I will ask you again tomorrow. Just get back with the answer for that.
Yes, ma'am.
Next question. In digital logic design, how can we design a XOR gate using 2x1 multiplexer?
Yes ma'am, I can.
ఏంటి అంతసేపు డ్రా చేస్తున్నారు? ఏంటి అంతసేపు?
కన్ఫ్యూజన్ మ్యామ్ చిన్నగా.
ఎందుకో కన్ఫ్యూజన్? ఇఫ్ ఎనీ వన్ ఆఫ్ ద సెలెక్షన్ లైన్, ఇఫ్ ఎనీ వన్ ఆఫ్ ద ఇన్పుట్ సెలెక్షన్ లైన్ అయితే అవుట్పుట్ ఏమొస్తుంది నెక్స్ట్ ఇన్పుట్కి?
అది డిపెండ్స్ అపాన్ ఇన్పుట్ మ్యామ్. అది జీరో అయితే
ఎక్స్ఆర్కి నేను చెప్పింది.
ఎనీ వన్ ఆఫ్ ది ఇన్పుట్ ఈజ్ 1 అయితే 1 వస్తుంది మ్యామ్ అవుట్పుట్.
బిఈ బి బార్.
ఎస్ మ్యామ్.
నెక్స్ట్, what is the minimum number of flip-flops required to design a mod 20 counter? Mod 20 counter. How many flip-flops are required to design a mod 20 counter?
20 ma'am. 20 minus 1 ma'am. 9. 20. We require 20.
How many minimum number of flip-flops required to design mod 20 counter?
Mod 20 under 20. 21 ma'am. N plus 1. 21 counters. And 21 flip-flops ma'am. 21 flip-flops.
How?
Sorry ma'am, it's we need 5 flip-flops only. 5 flip-flops.
What is mean by gray code? What is the use of gray code in digital?
Yeah, gray code we use it in K-maps ma'am, and it don't have any base value. That's it ma'am.
Okay. What is the difference between latch and a flip-flop?
Latch is level sensitive ma'am, trigger is edge sensitive, and latches don't have any clock signal. Flip-flops have clock signals.
Latch is a level sensitive, trigger is a
Edge sensitive.
trigger.
Flip-flop is a edge sensitive. latches and level sensitive, and latches don't have any clock signal. In latches we use enable signal. In flip-flop we use clock signal, ma'am.
Okay, fine. Last question. Can you tell me what are the limitations of Verilog HDL and what are the advantages of SystemVerilog?
Yes, ma'am. First thing, we don't have any controllability on randomization, and Verilog is static in nature. Here, SystemVerilog is in dynamic nature, and we don't have any OOPS concepts in Verilog, and we have OOPS concept in SystemVerilog, and we don't have an coverage reports while we writing code. While we writing test bench and test cases in Verilog, and we have coverage report in SystemVerilog and
Coverage concept.
coverage concept.
Okay, can you explain me brief about coverage concept?
Coverage is nothing but how much design validation is completed, like how many test cases are passed through our design. That's what the coverage.
How much design is covered?
Covered.
Functionality wise.
Yes.
Okay. Some more limitations.
Some more limitations. And we don't have here we have multiple array types. Here we have static array, dynamic array, associative arrays, and we only use static arrays, and we cannot change any size of object or size of memory while running the design in Verilog. Here we can change the size according to our requirement during runtime. And test bench. Here in coming to Verilog, we will directly write test bench using the module name, but it's difficult to write for n number of inputs. So it's when we go to SystemVerilog, it becomes easier to call or write that kind of n input design for testing.
Okay, good, but you need to improve more conceptually how detailed you can explain, like limitations of Verilog and advantages of SystemVerilog. We already discussed and have a notes. You need to just revise the notes, and also some even multiplexer you are failed to design. There are a lot of questions we can discuss in the further rounds, and just calculate the FIFO depth.
Yes,
okay, depth of the FIFO, and show to me tomorrow.
Yes, ma'am. Thank you.